Welcome to this video on atomic structure. We will cover the essential concepts of atoms, including the roles of protons, neutrons, and electrons to help you master the basics for your GCSE Physics exam. Everything in the universe is made of atoms. These particles are so incredibly tiny that millions could fit on a single full stop. Understanding atoms is fundamental to both chemistry and physics. At the center of an atom is a dense nucleus, which contains protons and neutrons. Surrounding this nucleus are electrons that orbit at a distance within the empty space of the atom. Inside the nucleus, we find protons and neutrons. Protons are positively charged, and their count identifies the element. Neutrons are neutral and contribute to the atom's total mass. Electrons are negatively charged particles that orbit in shells. They have very little mass. In a neutral atom, the number of electrons matches the number of protons, resulting in an overall charge of 0. This table summarizes the subatomic particles. Protons are positive and in the nucleus, neutrons are neutral and in the nucleus, and electrons are negative and orbit the nucleus. Most of an atom is actually empty space. If an atom were the size of a stadium, the nucleus would be like a small marble in the center, with electrons orbiting far away in the stands. The nucleus is incredibly small, yet it holds almost all the atom's mass. Because protons and neutrons are much heavier than electrons, the density of the nucleus is extremely high. The atomic number represents the number of protons in an atom's nucleus. This number defines the element and determines its position on the periodic table. The mass number is the total of protons plus neutrons. Electrons have negligible mass, so they are not included in this count. Remember, the mass number is always a whole number. You can find the number of neutrons by subtracting the atomic number from the mass number. For example, in carbon-12, subtracting 6 protons leaves 6 neutrons. Each element has a unique atomic number. Hydrogen has 1 proton, helium has 2, and lithium has 3. This difference in proton count is what makes each element chemically distinct. It is an important principle that all atoms of the same element must have the same number of protons. Changing the proton number changes the identity of the element entirely. Not all atoms of the same element are identical. Variations with different numbers of neutrons are called isotopes. Understanding these is essential for your studies. To summarize, isotopes have the same number of protons, meaning the same atomic number, but they have a different number of neutrons, which affects their mass number. They behave similarly in chemical reactions. Let's look at a practical example of isotopes with carbon. Carbon-12, carbon-13, and carbon-14 all have 6 protons, but they contain 6, 7, and 8 neutrons respectively, giving each a different mass number. Hydrogen is another great example. Protium has 1 proton and no neutrons. Deuterium has 1 neutron, and the rare radioactive tritium contains 2 neutrons. Despite these differences, all 3 remain hydrogen. Remember this key definition. Isotopes are atoms of the same element with the same atomic number but different mass numbers due to a varying number of neutrons. Why are atoms usually electrically neutral? It is because the positive charge of the protons in the nucleus is exactly balanced by the negative charge of the electrons orbiting it. When this balance is broken, the atom becomes an ion. Gaining electrons creates a negative ion, while losing them results in a positive ion. This process is the foundation of ionic bonding. Here is a quick summary of charges. Protons are positive, electrons are negative, and neutrons carry no charge at all. Their interaction is what keeps the atomic structure stable. Where does the mass come from? Almost all of it is in the nucleus. Protons and neutrons each have a relative mass of 1, while an electron's mass is so tiny, it is practically 0. To put the scale into perspective, over 99.9% of an atom's mass is found in the nucleus. Electrons are nearly 2,000 times lighter than a proton, and atoms themselves are unimaginably small. Atomic notation tells us everything we need to know. The mass number is at the top left, and the atomic number is at the bottom left. Subtracting the two gives you the number of neutrons. Let's apply this to sodium. With an atomic number of 11, we know it has 11 protons and 11 electrons. A mass number of 23 means it contains 12 neutrons, calculated by subtracting 11 from 23. Now consider oxygen. Standard OXY-GEN16 has 8 protons and 8 neutrons. In contrast, the isotope OXY-GEN18 still has 8 protons, but it contains 10 neutrons, which is why it is heavier. As you prepare for your exams, it is helpful to understand the most common types of questions you will encounter regarding atomic structure. Expect questions asking you to state the number of subatomic particles in a given atom, define isotopes, or recall the electrical charges of protons, neutrons, and electrons. When asked to identify isotopes, look for atoms of the same element that have the same number of protons but different neutron counts. Nitrogen or oxygen might be used as distractors. Finally, here's your most important exam tip. Keep the formula in mind that the atomic number equals the proton count, and the mass number equals the total of protons and neutrons combined. Let's review some key terms. The atomic number is the count of protons in the nucleus. It defines the element and equals the electron count in a neutral atom. The mass number is the total of protons and neutrons, while isotopes are atoms of the same element with different neutron numbers. Test your knowledge with these quick-fire facts. Is it true that the nucleus contains protons and neutrons? Yes. Is it true that electrons orbit the nucleus rather than reside inside it? Yes. Ensure you can distinguish between these atomic components quickly. Looking at the atom as a whole, remember that it consists of a dense, central nucleus surrounded by electrons in various shells. Despite its importance, the nucleus occupies only a tiny fraction of the atom's total volume. This table is essential. Protons are in the nucleus with a positive charge and a relative mass of 1. Neutrons are also in the nucleus, neutral with a mass of 1. Electrons orbit in shells, carry a negative charge, and have negligible mass. Visualizing the atom helps solidify these concepts. The nucleus holds the identity of the element through protons and adds mass through neutrons. Electrons define the charge and reactivity by occupying shells outside the core. To revise effectively, don't just read your notes. Atomic structure is a core topic, so focusing your energy here will pay off. Use active recall to test your understanding of the definitions we have covered. Follow these 4 tips for success. First, memorize definitions precisely. Second, practice calculating particles from notation until it is automatic. Third, use flashcards for particle properties. Fourth, complete as many past paper questions as possible. Avoid these common traps. Never confuse the atomic number with the mass number. The atomic number is always smaller. Remember that isotopes are the same element, and never include electrons when calculating the mass number. To summarize, atoms are the fundamental building blocks of matter. The nucleus contains the mass, while electrons define the chemistry. Remember the rules for calculating neutrons, identifying isotopes, and maintaining neutral charge to excel on your exam. You have got this. Mastering atomic structure is all about logical relationships between protons, neutrons, and electrons. Keep your definitions clear and your calculations sharp, and you will be well prepared to score full marks.